The morning fog clung to the forest floor like a burial shroud, thick and cold across the Hürtgen, where fallen leaves mixed with brass casings and the iron smell of consequence. It was November 7th, 1944, and inside a commandeered stone cottage turned field laboratory, 3 German engineers stood in uncomfortable silence around a weapon that should not have existed. On the wooden table before them, stripped of its mounting and trailing a length of ammunition belt like mechanical intestines, lay an American Browning M2 heavy machine gun. The metal was scarred, pitted with use, the barrel still faintly warm from whatever violence had claimed its previous operator. But it was the cartridges themselves that drew the eye. 12.7mm rounds, each one as thick as a man's thumb, gleaming dully in the weak light filtering through shattered windows. Hauptmann Friedrich Müller, formerly of the Mauser works in Oberndorf before the war requisitioned his expertise, lifted one of the massive cartridges with something approaching reverence. The weight surprised him, 63.5 grams. The brass case alone measured 99mm in length. He had spent 15 years designing machine gun ammunition, had helped refine the 7.92mm Mauser round that fed their vaunted MG42. But this American creation was something altogether different. Behind him, young Lieutenant Kraus, barely 23 and fresh from technical school in Dresden, shifted nervously. "Sir, the intelligence briefing suggested these were primarily anti-aircraft weapons, vehicle-mounted. Surely not meant for direct infantry engagement." Müller did not look up from the cartridge he was examining. "Intelligence," he said quietly, "has been wrong about many things lately." The third man, Oberleutnant Werner Steiner, a veteran of the Eastern Front who wore his Knight's Cross like a burden rather than an honor, moved to the window. Through the broken glass he could see the tree line where American forces had been reported advancing. Somewhere out there, more of these weapons waited. "How many of these do they have?" he asked. "Production estimates," Müller replied, still studying the ammunition, "suggest the Americans have manufactured nearly 2 million of these machine guns since 1933. Ground variants, aircraft variants. The M2 HB alone, the heavy barrel ground version, accounts for approximately 350,000 units produced during the war years." The silence that followed was heavy with implication. Germany had produced roughly 423,000 MG42s since its introduction in 1942. Their finest, fastest-firing machine gun in the world, and the Americans had nearly 5 times that number of these heavy weapons alone, not counting their standard infantry machine guns. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Kraus broke the silence, his voice carrying the forced enthusiasm of youth trying to convince itself. "But our MG42 fires 1,200 rounds per minute, 1,500 on some models. The intelligence reports say this American weapon fires only 450 to 575 rounds per minute. Half our rate, perhaps less." "Fetch the technical manual," Müller instructed, his tone suggesting he had already reached conclusions the younger man had not. "The one we captured with the weapon." The manual, when produced, was a slim thing compared to German technical documents. American military efficiency, Müller noted, extended even to their paperwork. Where German ordnance manuals ran to hundreds of pages, lavish with diagrams and mathematical proofs, this American field manual was direct, almost brutally simple. He read aloud, translating as he went. "Caliber, .5, 0 inches, 12.7 millimeters. Cartridge, .5, 0 BMG, Browning machine gun. Muzzle velocity, 2,840 feet per second, 866 meters per second. He paused, running the calculations in his head. Muzzle energy, approximately 13,000 foot-pounds, 17,600 joules. Steiner, who understood combat more than physics, frowned. "In German? Our standard 7.92mm round," Müller explained, "generates approximately 3,700 joules of energy at the muzzle. This American cartridge produces nearly 5 times that force, per bullet." The implications settled over them like fallout. Their MG42 might fire twice as fast, might create that distinctive sound the Allies called Hitler's buzzsaw, that continuous ripping noise that struck fear into enemy infantry. But each individual round carried only a fraction of the destructive power concentrated in these American behemoths. "It changes the equation," Müller continued, his voice taking on the careful precision of a man presenting uncomfortable mathematics. Our advantage in rate of fire, which we calculated as roughly 2 to 1, is negated by their advantage in energy per round, which approaches 5 to 1. The result is that even firing half as fast, the American weapon delivers more total destructive energy on target over any given period of sustained fire. Young Kraus was shaking his head, still clinging to what he had been taught. But accuracy suffers with such heavy rounds, and barrel life must be terrible. These are the trade-offs we learned about. The reasons for our design philosophy. Then let us test that philosophy, Müller said quietly. Gegen reality. They spent the next 2 hours methodically examining the weapon. Every German firearms engineer knew the legend of John Moses Browning, the American Mormon gunsmith whose designs had defined modern firearms. The M1911 pistol, the Auto 5 shotgun, the M1919 machine gun, and this, the M2, his final and perhaps greatest creation, finished near the end of the Great War and refined in the decades since. The engineering was elegant in its brutality. Unlike the MG42's complex recoil operation with its rotating bolt, the Browning used a simpler short recoil system. The barrel and bolt recoiled together for a short distance, locked by a simple but effective mechanism, then separated as the barrel stopped and the bolt continued rearward, extracting the spent case, cocking the firing pin, and stripping a fresh round from the belt on its return journey. Fewer moving parts than our design, Müller observed, running his fingers along the bolt assembly. Simpler manufacturing. The American obsession with mass production extends even to mechanical philosophy. Crude, Kraus suggested. Effective, Steiner corrected. There is a difference. The barrel itself was a work of practical genius. The heavy barrel variant, the HB designation, measured 56.5 centimeters long and weighed substantially more than the barrel of their MG42. Where German engineering had focused on rapid barrel changes to manage heat, the Americans had simply added mass. More metal meant more heat capacity, slower temperature rise, longer sustained fire before barrel changes became necessary. They sacrificed mobility for endurance, Müller noted, making annotations in his field journal. Their infantry squads do not move this weapon quickly, but once positioned, it can fire longer without pause than our designs. They examined the ammunition feed system next. The metallic link belt, each cartridge held in place by a stamped steel clip that separated automatically as the round was chambered. Simple, reliable, and capable of being loaded with mixed ammunition types, tracer rounds, armor-piercing rounds, incendiary rounds, standard ball ammunition, all fed together in any sequence the gunner required. No cloth belts, Steiner observed. No jams from water-soaked fabric, no deterioration in storage. The links can be connected and disconnected by hand, quickly, even in darkness. Müller was studying the ammunition types more closely now, particularly the armor-piercing variant. The cartridge was clearly marked, a black tip on the bullet identifying it as M2 armor-piercing. The technical data he had gathered indicated this round could completely perforate 22.2 millimeters of face-hardened armor plate at 100 yards, 19 millimeters at 500 yards. He pulled out comparison data for their own 7.92 millimeter armor-piercing round. At 100 meters, it could penetrate 5 millimeters of steel. At 600 meters, 3 millimeters. The Americans weren't building a machine gun. They were building anti-material weapons, firearms capable of destroying fortifications, vehicles, equipment, not merely suppressing personnel. It was a different philosophy of warfare entirely. "We need to fire it," Steiner said. "Speculation and measurement only tell us so much." They set up a testing range in a clearing behind the cottage, well away from the front lines, but close enough that the sound of artillery provided constant background accompaniment. Targets were prepared: sandbags, timber, a section of armor plate salvaged from a destroyed Sherman tank, 15 millimeters thick. Müller loaded the ammunition belt himself, hands practiced from years of technical work despite the unfamiliar mechanism. 50 rounds, a mix of ball and armor-piercing ammunition loaded in alternating sequence, as the captured American crew might have done. The weapon was mounted on its tripod, the M3 model that had been captured along with the gun. Heavy, stable, with traversing and elevating mechanisms that, while cruder than German optical systems, were robust and battle-ready. Steiner, who had more trigger time than either of the others, took the position behind the gun. His hands found the spade grips naturally, thumb resting on the butterfly trigger. The safety was off. The bolt was charged. 150 meters to the targets. "Ready," he said. "Fire," Müller ordered. The sound was not what they expected. German machine guns, even the mighty MG42, produced a high, angry bark, a mechanical scream of violence. This American weapon made a different noise entirely. Each round was a deep, percussive boom, a sound felt in the chest as much as heard with the ears. Even at the reduced rate of fire, 450 rounds per minute, it was a continuous, hammering thunder. The first burst, 10 rounds in just over 1 second, tore across the test range with visible authority. The tracers showed the path, bright orange lines connecting muzzle to target, and where they struck, destruction followed. Sandbags didn't just absorb the impacts. They exploded, literally burst apart, sand and fabric atomized by the kinetic energy transfer. The timber target, heavy pine logs stacked 3 deep, shattered like kindling. "Cease fire," Müller called, but his voice was barely audible over the continued hammering. Steiner had to see the hand signal to stop. In the sudden silence, their ears ringing despite the cotton wool protection, they walked forward to examine the damage. The sandbags were completely destroyed, completely. The timber, intended to simulate a wooden building or bunker wall, showed penetration through all 3 logs. The armor plate had a clean hole punched through it, edges deformed inward, the metal around the impact showing stress fractures from the shock. Young Kraus was staring at the armor plate, his face pale. "Our anti-tank rifles," he said quietly, "struggle to penetrate 15 millimeters at close range. This machine gun, it went through like paper." "Not a machine gun," Steiner said, his voice carrying the weight of recognition. "An automatic cannon that fires like a machine gun. That is what we are facing." They conducted more tests through the afternoon. Longer bursts, sustained fire, accuracy testing at various ranges. The weapon performed consistently, reliably. Barrel temperature rose, yes, but slowly, the heavy barrel mass absorbing heat that would have warped a lighter barrel. Accuracy remained acceptable, not precision but combat effective, out to ranges exceeding 1,000 meters. Müller conducted calculations, filling pages in his journal with figures and observations. The weapon weighed 38 kilograms unloaded, roughly twice what an MG42 weighed, but could be carried by 2 men in its broken-down state. The tripod added another 20 kilograms, but provided a stable platform comparable to their own Lafette 42 tripod mount. The Americans had sacrificed lightweight mobility for sustained firepower, a trade-off that made sense when viewed through the lens of American tactical doctrine. Their infantry tactics, Müller knew from captured documents and intelligence reports, emphasized overwhelming firepower to suppress the enemy, then maneuver under that suppression. The .50 caliber provided suppression at weights and ranges that rifle-caliber machine guns could not match. They used these as base-of-fire weapons, he explained to the others as they cleaned and inspected the weapon after testing. Positioned on the flanks or in overwatch, while lighter machine guns advance with the infantry, these weapons remain stationary, pouring fire into defensive positions, destroying cover, forcing our troops to keep their heads down. By the time their infantry closes, our defensive positions are suppressed, damaged, demoralized. Steiner was nodding slowly, his expression grim. "We have seen this on the Western Front. The American tactic. They do not advance until they have established fire superiority. They will expend ammunition freely, thousands of rounds, to destroy positions that we would assault directly. It seems wasteful until you see the casualty ratios. It is not wasteful if they have the ammunition to spare," Müller countered, "and by every indication they do. American industrial capacity is producing ammunition at rates we cannot match. Each American machine gun, they estimate, has access to tens of thousands of rounds in supply. Our crews ration ammunition because supply is limited. They do not." The evening was drawing in, bringing with it the cold that settled over the forest like judgment. Inside the cottage, working by lamplight, Müller began compiling his formal report. The structure was familiar: technical specifications, performance testing results, tactical implications. But the conclusions he was reaching went beyond mere technical assessment. "The weapon represents a fundamental difference in American military philosophy," he wrote, in careful, precise script. Where German engineering emphasizes efficiency, rapid fire from lighter cartridges, and mechanical excellence, American design emphasizes raw power, mechanical simplicity, and reliability under adverse conditions. The M2 Browning is not attempting to achieve German standards of precision. It is operating by a different standard entirely: overwhelming force, applied continuously, at ranges that render German defensive positions untenable. He continued, "Tactical implications are severe. Our current defensive doctrine assumes German machine gun positions can suppress American advances through superior rate of fire. However, American heavy machine guns operating at medium to long range can destroy German positions before their infantry comes within effective range of our defensive fires. The .50 caliber does not suppress, it destroys. A cover that is adequate against 7.92 mm fire is penetrated by 12.7 mm ammunition. Fortifications must be substantially heavier to provide equivalent protection." The most damning paragraph came last. Recommendation: German forces must acknowledge that in the category of heavy machine guns, we have no equivalent weapon. The MG42, while tactically superior in rate of fire for light infantry support, cannot fulfill the role that the American .50 caliber performs. Development of a comparable weapon system should be undertaken with highest priority. However, given current industrial capacity and raw material limitations, it is unlikely such development could reach production before war's end. In the interim, tactical doctrine must be adjusted to account for American heavy machine gun superiority at ranges exceeding 600 meters. He signed the report, dated it, and sealed it in an envelope marked for delivery to Wehrmacht Ordnance headquarters in Berlin. Whether it would arrive, whether it would be read, whether anything would come of his recommendations, Müller could not say. The war was not going well. Everyone knew this, though speaking such truth openly was dangerous. Young Kraus had been reading over his shoulder. "Sir," he said hesitantly, "is it wise to be so frank, about American superiority?" Müller looked at him for a long moment. "Lieutenant, I have spent my career in pursuit of mechanical truth. Ball bearings roll because of mathematics, not ideology. Steel fails at certain stress levels regardless of the flag flying above the foundry. The Americans have built a superior heavy machine gun. That is simply a fact. If my frank assessment of that fact is unwelcome in Berlin, then Berlin has larger problems than my report can address." Steiner, cleaning his rifle by the window, spoke without turning. "The problem," he said quietly, "is not that we lack the engineering skill to build such weapons. We have brilliant engineers. The problem is that we lack the industrial capacity the Americans possess. They can afford to build heavier weapons because they have unlimited steel, unlimited copper for brass, unlimited manufacturing capacity. We make trade-offs, choose lighter calibers and faster fire rates, because we cannot afford the raw materials for millions of heavy machine guns. Their .50 caliber cartridge uses twice the brass, twice the powder, heavier bullets. Multiply that by billions of rounds, and you see the difference between our economies." It was, Müller reflected, perhaps the most honest military assessment he had heard in months. The German war machine was running on fumes, creativity, and desperation. The Americans were running on oil, steel, and industrial capacity that dwarfed anything Germany had ever possessed, even at peak production in 1942. They spent the night in the cottage, taking turns on watch, though the front seemed quiet for once. In the darkness, Müller found himself thinking about the weapon sitting disassembled on the table. John Browning had died in Belgium in 1926, in Fabrique National's offices, working on yet another firearms design. He never saw his .50 caliber machine gun become the legend it would be, never knew that his creation would serve in every theater of the Second Great War, that it would remain in service long after war's end, that German engineers would handle his work with grudging, uncomfortable respect. The Americans called it Mar-Deuce, an affectionate nickname for M2. Soldiers anthropomorphized their weapons, gave them personalities, treated them as companions rather than tools. It spoke to something in the American character, perhaps, that casual familiarity with violence, that matter-of-fact acceptance of mechanical destruction as just another job to be done efficiently. German military culture was different. Weapons were instruments of duty, extensions of discipline and training. You did not name your rifle. You maintained it to exacting standards and employed it as doctrine dictated. The Americans seemed more pragmatic, more willing to adapt doctrine to circumstances, less bound by tradition and theory. Morning came with frost and distant artillery. A motorcycle courier arrived with orders. The cottage was to be evacuated. American forces had broken through the line 15 kilometers south. Encirclement was possible. All equipment was to be destroyed or evacuated. Priority was given to technical intelligence and personnel. They loaded the Browning onto a truck, along with the ammunition and technical documents. Müller took a last look at the cottage, at the testing range outside, at the evidence of American firepower still visible in shattered targets and torn earth. As the truck pulled away, heading east toward uncertain safety, Krauss asked the question that had been bothering him. "Sir, if we know the Americans have such weapons, why do we continue to fight? If their industrial advantage is so overwhelming?" It was Steiner who answered, his voice tired beyond his years. "Because, Lieutenant, wars are not decided by single weapon systems, no matter how superior. They are decided by will, by politics, by factors beyond our control as soldiers and engineers. We do our duty. We provide accurate technical assessments. We adapt where we can. The larger questions of victory and defeat, those are for others to decide." But Müller, watching the German countryside roll past through the truck's canvas cover, suspected that those larger questions had already been decided. They simply had not yet received the official notification. The 50 caliber Browning, riding secure in its crate beside them, was not just a weapon. It was evidence, proof of an industrial system that could afford to build machine guns weighing 38 kilograms and firing ammunition that cost 5 times what German machine gun rounds cost. Proof of an economy that viewed such profligacy as merely standard issue. Proof that Germany was fighting not just an enemy, but a force of nature, mechanical and inexorable as a factory assembly line. The truck reached the Waffenamt testing facility outside Kummersdorf 3 days later, after a journey marked by detours around, bombed roads and nervous waits in forests, while American fighter bombers prowled overhead. The facility itself was a shadow of its former glory. Buildings damaged by previous air raids, personnel reduced, resources stretched thin. But it remained operational, still conducting the technical assessments that someone in Berlin believed might yet turn the tide. Müller was ushered into an office where a collection of senior officers waited, men whose decorations spoke of the Eastern Front, of Africa, of years of war that had aged them beyond their chronological years. The most senior, General Major Klaus Reinhardt, had been involved in weapons procurement since before the Polish campaign. His eyes were hard but not unkind. "Your preliminary report made interesting reading, Hauptmann," Reinhardt said without preamble. "You claim the American heavy machine gun is, in your words, categorically superior to our MG42. Those are strong words for a weapon that fires half as fast." "Yes, sir," Müller replied, standing at attention. "Strong words for a strong weapon." "Explain." Müller had prepared for this. He unrolled a series of technical drawings and comparison charts on the conference table. "The comparison of rate of fire alone is misleading, sir. It is analogous to comparing the speed of 2 vehicles without considering their payloads. Yes, the MG42 fires 1,200 rounds per minute to the Browning's 450. But the Browning fires cartridges with nearly 5 times the kinetic energy. The total energy delivered on target per minute actually favors the American weapon." He pointed to calculations on the chart. MG42, 1,200 rounds per minute, multiplied by 3,700 joules per round, equals 4.44 megajoules per minute. Browning M2, 450 rounds per minute, multiplied by 17,600 joules per round, equals 7.92 megajoules per minute. Nearly twice the destructive energy, despite the slower rate of fire. One of the other officers, an Oberst with an artillery background, leaned forward. "But surely accuracy suffers. Heavier recoil, less controllable? The weapon is mounted, sir. Always. The Americans do not fire it from the shoulder. The tripod mount, combined with the weapon's own mass, absorbs the recoil. And because the rate of fire is slower, the recoil impulses are more manageable. Our tests showed combat-effective accuracy out to 1,200 meters. Against area targets, useful fire extends beyond 2,000 meters. "Impossible," someone muttered. "I have photographic evidence of the test results, sir, and the weapon itself, if you wish to conduct independent testing." Reinhardt studied the charts in silence for a long moment. Ammunition consumption must be prohibitive. Such heavy rounds, at even moderate rates of fire. Indeed, sir, each 50 caliber cartridge weighs approximately 115 grams complete. Our 7.92mm round weighs 27 grams. The American round requires 4 times the brass, 3 times the powder, and substantially more lead. From a logistics perspective, supporting these weapons should be impossible. And yet, Reinhardt prompted, hearing the unspoken continuation. And yet they do it anyway, sir. American industrial production operates at scales we cannot match. Intelligence estimates suggest they have produced nearly 2 million of these heavy machine guns. The ammunition production figures, if accurate, exceed 2 billion rounds. They have the industrial capacity to support weapons we would consider logistically impractical. The room fell silent. Numbers had a way of cutting through ideology, politics, and wishful thinking. 2 billion rounds. The figure represented more brass than Germany could produce in years, more powder than their chemical industry could manufacture, more industrial capacity than they had ever possessed, even in peacetime. Steiner, who had accompanied Müller to provide tactical perspective, spoke up. "Sir, if I may, I have faced these weapons on the Western Front. The tactical reality is that American heavy machine guns can engage our positions from ranges where our defensive fires are ineffective. They destroy fighting positions, not merely suppress them. Sandbag emplacements, wooden bunkers, even light armored vehicles, all are vulnerable. When their infantry advances, they do so under a covering fire that makes effective defense nearly impossible." Another officer, younger, still clinging to doctrine, objected. "Then our tactics must change. We concentrate on MG42s, achieving local fire superiority through numbers and rate of fire." "With respect, sir," Steiner replied, his voice level but firm, "that assumes we have the ammunition to sustain such fire. Our supply situation does not permit expenditure at American rates. And it assumes our positions survive long enough to engage. American artillery and airstrikes precede their infantry advances. By the time their ground forces move forward, supported by these heavy machine guns, our defensive positions are already compromised." Reinhardt made a note on his pad. "What are your recommendations, Hauptmann Müller?" "Immediate recommendations, sir. Tactical doctrine should be modified to account for American heavy machine gun fire. Defensive positions require heavier construction, ideally concrete or deep earthworks, not merely sandbags. Positions should be sited to offer protection from plunging fire at long range. Counter-battery fire should prioritize American machine gun positions when possible, though their mobility makes this difficult." He paused, then continued. "Long-term recommendations. Germany should develop a comparable heavy machine gun system. However, I must be frank, sir, given our current industrial limitations, raw material shortages, and production priorities, such development would likely not reach field deployment before war's end. The resources required for a new heavy machine gun program would be better allocated to existing priorities." The euphemism was not lost on anyone in the room. Before war's end, not before victory. The distinction spoke volumes about the situation Germany found itself facing in late 1944. Reinhardt nodded slowly. "Your assessment will be forwarded to OKW with my endorsement. In the meantime, I want comprehensive testing conducted here at Kummersdorf. Penetration tests against various materials and armor thicknesses. Endurance testing to failure. Ammunition analysis. Everything. I want data we can distribute to field units, information they can use for tactical planning." "Yes, sir." "And Hauptmann, one more thing." Reinhardt's expression was grave. "Your report mentioned American industrial capacity multiple times. Your conclusions suggest that weapon systems alone cannot overcome such industrial disparity. I am not asking you to revise your technical assessment, but I want you to understand that such conclusions, while perhaps mathematically accurate, are politically sensitive. Some might call them defeatist." Müller met his gaze steadily. "Sir, I am an engineer, not a politician. I report what mathematics tells me. If my calculations are defeatist, then mathematics itself is defeatist." A faint smile crossed Reinhardt's face. "Spoken like an engineer. Very well. Conduct your testing, compile your data, and Hauptmann, be careful. Not everyone appreciates uncomfortable truths, no matter how well documented." The testing at Kummersdorf took 3 weeks, a comprehensive examination that revealed layer upon layer of American engineering philosophy. The weapon was disassembled completely. every component measured, weighed, and analyzed. Metallurgical samples were taken from the barrel, the bolt, the receiver. The steel alloys were good but not exceptional, industrial grades rather than specialized formulations. The Americans were building to adequate standards rather than optimal ones, accepting slightly lower performance in exchange for vastly simpler manufacturing. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The barrel rifling was examined under magnification. 4 grooves and lands, right-hand twist, 1 turn in 15 inches. The rifling depth was consistent, the manufacturing quality good but achievable with standard industrial equipment. German barrels often featured more complex rifling patterns, tighter tolerances, superior surface finish. But German barrels also required more machine time, more skilled labor, more expensive equipment. They have optimized for mass production, Müller observed to his testing team. Every design choice reduces manufacturing complexity. Stamped parts where we would use milled components, welded assemblies instead of precision castings, looser tolerances that still achieve functional reliability. It is brilliant in its own way. Not brilliant engineering in the traditional sense, but brilliant industrial design. The ammunition testing was particularly revealing. German chemists analyzed the powder composition, finding a double-base propellant similar to German formulations, but loaded to higher pressures. The primers were standard Boxer type, simple and reliable. The bullets themselves were engineering marvels of a different sort, designed not for maximum accuracy, but for maximum effect. The armor-piercing round, designated M2, featured a hardened steel core surrounded by a gilding metal jacket. Upon impact with armor, the core would penetrate while the jacket stripped away, concentrating energy on a small point. The penetration figures Müller had cited in his initial report were confirmed and exceeded. At 100 meters, the round could penetrate 23 millimeters of face-hardened armor. At 500 meters, 19 millimeters. These were performance levels that German machine gun rounds could not approach. The incendiary rounds were equally impressive, featuring a small explosive charge that detonated on impact, useful for igniting fuel tanks and ammunition. The tracer rounds allowed gunners to observe their fire and adjust aim, a practical consideration in combat. American doctrine called for mixing ammunition types in the belt, creating a versatile load that could engage various targets without requiring ammunition changes. Endurance testing pushed the weapon to failure. The team fired continuous bursts, pausing only to change barrels as they heated beyond safe limits. The barrel change procedure, which American manuals claimed could be done in under 10 seconds by trained crews, was practiced and timed. German soldiers, following the translated instructions, achieved barrel changes in 12 to 15 seconds, slowed slightly by unfamiliarity with the mechanism, but still remarkably fast for such a heavy weapon. The weapon fired over 10,000 rounds before experiencing its first significant malfunction, a broken firing pin that was easily replaced. After repair, testing continued. By the time the testing was complete, more than 30,000 rounds had been fired through the single weapon. The barrel showed wear but remained serviceable. The receiver showed no cracks or stress failures. The weapon was, in the parlance of engineering, overbuilt, designed with safety margins that allowed it to absorb abuse that would have destroyed lighter weapons. The Americans build for reliability over elegance, Müller wrote in his expanded technical report, where German engineering seeks to optimize every parameter, balancing weight, strength, and performance to achieve maximum efficiency. American engineering appears to optimize for a single parameter. Does it work under adverse conditions? If reliability requires additional weight, they add weight. If simplicity requires accepting lower theoretical performance, they accept lower performance. The result is weapons that are heavier, slower firing, and less technically sophisticated than German equivalents, but which function reliably in conditions that would render German weapons inoperable, he continued. This philosophy extends to their entire industrial system. American factories are not building weapons to German standards of precision because they do not need to. Their standards, while lower, are adequate for combat requirements, and by accepting adequate rather than optimal, they achieve production rates that optimal German manufacturing cannot match. It is the difference between building one perfect machine and building 100 adequate machines. In war, the 100 adequate machines prevail. The tactical testing was conducted with German crews who had been captured and had agreed to demonstrate American weapons employment in exchange for better treatment. The psychological aspects of this were complex, but Müller was interested in tactics, not loyalties. The crews showed how American doctrine employed the .50 caliber. Typically, the weapon was positioned on a flank or in elevated terrain, providing overwatch for advancing infantry. While lighter machine guns moved with the advance, the .50 caliber provided base of fire, engaging enemy positions at ranges exceeding 800 meters. The heavy rounds punched through cover that would stop rifle caliber fire, destroying defensive positions and forcing German troops to remain under cover or retreat. They use it as a sniper weapon writ large, one of the cooperating prisoners explained, a former sergeant from Oklahoma who spoke some German. Herr, find a good position, preferably elevated, with clear fields of fire. Set up the gun, range the targets, then methodically destroy anything you can see. Buildings, vehicles, fighting positions. The infantry advances under our covering fire. By the time they reach the objective, most of the defenders are suppressed, wounded, or dead. How much ammunition does a typical gun carry? Müller asked. Depends on the situation. Defensive position, maybe 3,000 rounds or more. Assault, maybe 500 to 1,000. But resupply is constant. Our logistics can keep up with the expenditure. I never ran out of ammunition in combat, not once in 8 months in France. The contrast with German experience was stark. German machine gun crews rationed ammunition carefully, knowing resupply was uncertain. American crews fired freely, confident that more ammunition would arrive. It was yet another expression of industrial capacity, the ability to produce and deliver ammunition in quantities that rendered conservation unnecessary. The final report, compiled in early December 1944, ran to over 200 pages of technical data, test results, tactical assessments, and strategic implications. Müller signed it with the same careful precision he brought to all his work, then added a one-page executive summary that he knew would be the only section most officers would read. The American Browning M250 caliber heavy machine gun represents a category of weapon for which Germany has no equivalent. While inferior to the MG42 in rate of fire and portability, it is superior in range, penetration, and destructive effect. American doctrine employs these weapons in roles that German machine guns cannot fulfill, creating tactical advantages that cannot be countered with existing German weapon systems. Development of a comparable German heavy machine gun is technically feasible, but practically impossible given current industrial constraints. Recommendation: tactical doctrine must be adjusted to account for American heavy machine gun superiority. Defensive positions must be hardened against 12.7 mm fire. Counter-tactics should focus on limiting American ability to establish base of fire positions through aggressive patrol action and indirect fire. Long-term, Germany must acknowledge that in certain categories of weapons technology, American industrial capacity enables capabilities we cannot match. The report was classified and distributed to senior Wehrmacht and SS commands. Müller never learned how widely it was read or whether his recommendations were implemented. The war ground on, American forces pushed deeper into Germany, and the technical assessments of engineers became increasingly irrelevant compared to the brutal arithmetic of armies and industrial production. But in scattered German units, officers who had access to the report quietly adjusted their tactics. Fighting positions were dug deeper, reinforced with logs and earth rather than sandbags. Units avoided exposed positions where American overwatch could engage them at long range. When .50 caliber fire was encountered, German troops learned to seek substantial cover or withdraw rather than attempting to suppress the American position with rifle caliber fire. The weapon itself, the captured Browning that had been tested so thoroughly, eventually ended up in a storage facility, as the Kummersdorf facility was evacuated ahead of Soviet advances. It vanished in the chaos of Germany's collapse, likely seized by Soviet forces or destroyed to prevent capture. But the knowledge it had provided, the uncomfortable truths it had revealed about American industrial and military capabilities, persisted in the minds of those who had studied it. Years later, in the gray aftermath of defeat, Müller would find himself in American custody, part of Operation Paperclip, the program that brought German scientists and engineers to America. He worked briefly at Aberdeen Proving Ground in Maryland, the American weapons testing facility, and there he saw American weapons development up close. The Browning M2 was everywhere, mounted on vehicles, on fortifications, in testing ranges. American engineers spoke of it with casual familiarity, discussed modifications and improvements, debated whether it should be replaced with more modern designs. But even in 1949, 4 years after war's end, the M2 remained in frontline service, fundamentally unchanged from the weapon Müller had tested in that forest cottage in 1944. "Why don't you replace it? Why don't you replace it?" he asked an American ordnance officer one day, genuine curiosity overcoming his usual reserve. The American had shrugged. "Replace it with what? It works. It's reliable. We've got millions of rounds of ammunition in stock. The manufacturing infrastructure is established. Sure, we could design something more advanced, lighter maybe, faster firing, but would it be enough better to justify the cost of replacing millions of existing weapons? Military bureaucracy moves slow, and honestly, the Mardus does everything we need it to do." It was, Müller reflected, the most American answer possible, not pursuing perfection for its own sake, but satisfied with adequate performance from a proven system. The German mindset would have demanded continuous improvement, refinement, optimization. The American mindset accepted that good enough was, in fact, good enough. He never spoke publicly about his testing of the captured .50 caliber, never wrote memoirs or gave interviews about that period. The work he had done in German service was not something he wished to dwell on, regardless of how technical and apolitical he had tried to keep it. But privately, in notes he kept for his own reference, he wrote about the lessons he had learned. "The German engineer seeks elegance," he wrote. "We are trained to find the optimal solution, to balance competing requirements with mathematical precision, to achieve the best possible result within given constraints. This produces beautiful engineering, sophisticated systems, weapons that are marvels of mechanical achievement. But war does not reward elegance. It rewards reliability, numbers, and industrial capacity. The Americans understood this in ways we did not. They built adequate weapons in overwhelming numbers, supported by an industrial system that could sustain them. We built superior weapons in limited numbers, supported by an industrial system that could not keep pace with demand. In retrospect, the outcome was never in doubt. We lost the war in the factories of Detroit and Pittsburgh, not on the battlefields of Normandy and the Bulge. The MG42, Germany's finest machine gun, the buzzsaw that had terrified Allied infantry, remained in production even after war's end. Modified and modernized, it became the MG3, serving in the West German Bundeswehr and armies around the world. Its rate of fire, its mechanical elegance, its efficiency, all remained impressive. But it remained a light machine gun, firing rifle-caliber ammunition, suited for infantry support, but not for the heavy fire support role that the .50 caliber filled. Germany never did develop a comparable heavy machine gun. Post-war, the Bundeswehr simply adopted the American M2, acknowledging implicitly what Müller had concluded explicitly in 1944. Some American designs were, for their intended roles, simply better, not more elegant, not more sophisticated, but better in the ways that mattered for military effectiveness. The .50 caliber served in Korea, where its ability to engage Chinese mass infantry attacks proved invaluable. It served in Vietnam, mounted on vehicles, helicopters and patrol boats, its heavy punch effective against fortifications and light structures. It served in the Gulf War, in Iraq, in Afghanistan, in conflicts scattered across decades and continents. As of this writing, more than 80 years after its introduction, it remains in frontline service with American forces and dozens of other militaries worldwide. Few weapons in history can claim such longevity. The design has been updated, improved, modernized in details, but fundamentally remains John Browning's creation, a weapon designed near the end of the First World War and proven in every conflict since. It is a testament not to engineering elegance, but to engineering adequacy, to the principle that a weapon does not need to be perfect. It merely needs to work, reliably, in the hands of soldiers under combat conditions. And it works. After a century, through countless modifications of tactics and technology, it still works. In the end, that was the lesson Müller learned in that cold German forest in November 1944, examining a captured American weapon that should not have been as effective as it was. Elegance is admirable, sophistication is impressive, but reliability, simplicity, and industrial capacity, those are what win wars. The Americans had understood this. Germany had not, or had understood too late to matter. The report Müller wrote, the testing he conducted, the recommendations he made, all were technically accurate and strategically irrelevant. By the time German commands received his assessment, the war was already lost. American armies were crossing the Rhine, Soviet forces were pushing toward Berlin, and no amount of technical knowledge about 50-caliber machine guns could alter the fundamental arithmetic of industrial warfare. But the knowledge persisted. In military academies after the war, Müller's report was studied as an example of honest technical assessment, a model of how to evaluate enemy capabilities objectively. The testing methodology became a template for weapons evaluation, and the conclusions about the relationship between industrial capacity and military effectiveness influenced post-war thinking about defense production and logistics. The German military learned, painfully, that technical excellence alone could not overcome material disadvantage. That lesson, purchased at tremendous cost, shaped German defense policy for decades afterward. Never again would Germany attempt to outproduce industrial powers. Instead, post-war German military doctrine emphasized quality, training, and integration into larger alliance structures, where industrial capacity could be pooled and shared. The Americans, for their part, took different lessons from the war. Their industrial mobilization had been spectacularly successful. They had outproduced the Axis powers in every category of weapon, and they had done so while maintaining higher living standards at home than their enemies. The 50-caliber machine gun was just one small example of a larger truth. American industrial capacity, properly mobilized, was overwhelming. That confidence, that belief in American industrial and technological superiority, would shape American military thinking for the rest of the 20th century. Sometimes it was justified, sometimes it led to overconfidence and failure. But the fundamental lesson of World War II, that industrial capacity matters more than individual weapon excellence, remained embedded in American military doctrine. And so the 50 caliber persisted, a mechanical legacy of that doctrine, firing the same 12.7mm rounds that had so impressed and disturbed Friedrich Müller in 1944. Generations of American soldiers learned to field strip the weapon, to time the headspace, to load the belt and press the butterfly trigger. They called it Ma Deuce, with the same casual affection soldiers had used 80 years earlier. Some weapons become legends, others become institutions. The Browning M2 became both. In a storage facility in Maryland, among thousands of other weapons from dozens of wars, there sits a 50-caliber machine gun with a particular serial number, captured near the Hürtgen forest in November 1944, tested exhaustively at Kummersdorf, seized by Soviet forces, eventually traded back to American custody during the Cold War. It is indistinguishable from millions of others, but buried in archives. Are Müller's test reports, documenting its performance in meticulous detail. The weapon still functions. Were it to be loaded and fired today, it would perform exactly as it did 80 years ago. The same deep, hammering thunder, the same devastating effect on the target, the same reliable mechanical operation that so impressed its evaluators. Some machines are timeless not because they are perfect, but because they are adequate in all the ways that matter. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.